Okay, so hello everyone. Welcome you all to Intellipaat's workshop on Master SQL Fundamentals. So today's workshop will be conducted by Mr. Sai, who is an experienced analytical professional who loves to dig into data and draw insights that create business impact. He has extensive experience of working with Fortune 100 banking, technology, pharmaceutical, healthcare clients in sales, marketing, and customer service domains. He is specialized in building dashboards and reports that drive key business decisions. So, guys, let's welcome Mr. Sai into the session. Sir, over to you.
Hey, thank you. Thank you for the quick intro. Hey guys, welcome everyone to the webinar on mastering fundamentals of SQL. So I'm going to be the webinar host for the next 2 hours, where I would be walking you through the various concepts that are needed to be learned from SQL. Okay, so I have just laid down the topics that we would be discussing in the next 2 hours in this webinar. Okay, so we'll start off with very basics like understanding what is a database. Okay, so we often hear the word database, right? So we try to understand what a database is. Okay, so after that we'll discuss what is DBMS or database management systems. Okay, and then we'll discuss what is SQL as a language. Why is that SQL is important for us to learn in order to deal with the databases. Okay, so I'll just talk a few lines about what is SQL. Okay, then we discuss about what are the tables in SQL. Okay, and then we discuss about how to create a database and how can we drop a database. Okay, after that we discuss the topics like creating tables, and after creating a table we need to insert the data into those tables, right? So we'll see how the syntax for the same look like. Okay, and then we'll discuss the various clauses that are present in SQL, which helps us to build a query. Okay, so we have different clauses like select clause, from clause, where clause, group by clause, having clause, and order by clause. So I will walk you guys through the functionality of each of these clauses and also the syntax that we need to use to build a query. Okay, using all these clauses. Okay, after that I'll also discuss about what is top clause, and then let me also discuss about order of execution of various clauses. That is also very important. And then we'll discuss what are joins in SQL, and after that we'll discuss about subqueries, time permits. We can also discuss how can we delete the records from a table, and how can I update the records that are already present in the table. So these are the topics that we can discuss in this webinar. Okay, yeah guys, so without wasting any more time, let me get into the topics. Before that, I would also want to give a heads up that we would be using SQL Server Management Studio. Okay, so this is basically a platform on which we can write the queries to access the data present in the databases. So SQL Server Management Studio, or shortly it is also called as SSMS. So it is a tool from Microsoft. So we would be using SQL Server Management Studio to write all our SQL queries. So we often hear the word database, right? So what is the definition of a database? Okay, so if you look at the definition of the database, a database is nothing but it's an organized collection of data stored in an electronic format. Okay, so in today's world, we see tons and tons of data getting generated every second, right? So and data is getting generated everywhere throughout the world. Like if you open social media, there is tons and tons of data out there in various forms, right? You have audio data, you have video data, you have text data, right? So I mean, there is no dearth for data today. Like it's getting generated everywhere, right? If you go to a supermarket, a lot of sales happen in a supermarket, right? So every company like Walmart or Reliance or DMart, so they're all storing the customer transactions data in their databases. Okay, and if you ask me why they are storing that data, So data can be used for so many purposes, right? So they store the data to derive insights from that data, which can be used to devise a strategic marketing plan for their company. Okay, they also use the data to better understand the customer behavior. Okay, so data today is also used to do some forecasting. Okay, based on the historical data, they can extrapolate the curve and understand how the sales are going to be 5 years down the line, right? So data today can be used in a way that we could not even think of, right? So some companies are using data that extensively. We can't even imagine that they are using that data in such a way. Okay, so it has become extremely important for companies to what do you say, to store the data, to analyze it, and to better devise what do you say, to better strategize their business based on the data insights. Okay, so that is why if you hear any company's chief analytics officer or chief information officer, they talk about, always talk about something called as data driven decision making. Okay, so they often say this word, like in their speech, or when they are talking about what the strategy of the company, of their company, they often say this statement, right? So we are moving from a traditional decision making to a data driven decision making. Okay, so companies today are extensively relying upon data for all their decisions. Okay, and database is nothing but, it is an organized collection of data. When stored in an electronic format, it becomes a database. Okay, so to put it very simple in normal layman terms, so the data that you are storing, right, if you store it if you collect it in an organized way and store it somewhere on a server or a storage device, that becomes a database, as simple as that. And databases are represented using cylindrical symbols. Okay, the symbolic notation is in the form of a cylindrical shape. Okay, so having learned what a database is, then let's try to understand what is a database management system. So a database management system is nothing but it's a system software for creating and managing databases. Okay, so you have data sitting on a database. Okay, then how you as a user can access that database? There should be something in between for you to access that database, right? And by the way, they are not physical things, like you can't go and touch a database, right? It's a data that is stored in an electronic format, so it's an intangible thing, right? So there must be some software in the system which should help us to access the data that is present on a database, right? So the system software that helps us to create and manage databases is nothing but a database management system. So if you see the SQL Server Management Studio, which I have open in front of you, so this is one of the database management system. Okay, so it is a software which helps us to connect to the databases and access the data that is present on the databases. So you can do all sorts of functionalities with the help of SQL Server Management Studio. SQL Server Management Studio is an example of database management system. So that is about DBMS. Okay, now let's try and to understand what is SQL and where does SQL fit in this schema of things. Okay, so I told what a database is, and I also talked about what is database management system. Okay, then there should be some kind of a medium, right? So there should be some kind of a, what do you say, communication language which helps us to communicate with the databases, right? So we as humans have so many different languages to communicate between ourselves. We have Hindi, we have English, Telugu, Urdu, Kannada, Malayalam, Punjabi, Bengali, right? So we have so many different languages in India, and outside India also we have so many languages, world languages, right? So these languages helps us to communicate between the humans. Then how will you communicate with the databases? So a language, there should be some language, right, even to communicate with the databases. So that language is nothing but SQL, or structured query language. Okay, so SQL has been universally adopted as a standard language for communicating with the databases. Okay, so SQL stands for structured query language, which is a language of databases, I would say. So SQL is nothing but it stands for structured query language, which is a standard language for accessing and manipulating databases. Okay, to simply put, it is a language of databases. Now let's try to understand how the data is stored in database management systems. Okay, so the data that is being collected is stored in majority of the cases in the form of tables. So the data that you collect and store, it will be stored in the form of tables. Okay, so if you see what is a table is a database object which comprises of rows and columns. Okay, so the data is stored in a tabular format in relational database management systems, and they comprise of rows and columns. Okay, so the horizontal are called rows and the vertical entities are called columns. So if you see, there is a table that you are seeing on my screen, right? See that there are 6 columns and 6 records. Okay, 6 records or rows. Okay, so rows are also called records, columns are also called fields. Yeah guys, so this is one important terminology as far as SQL is concerned. There are rows and there are columns. Rows are also called as records and columns are also called as fields. Yeah, so if you see here, this is a table of employees. Okay, so every company or every organization has employees, right? And they do store the data of the employees in their database, right? uh, as long as you are the employee of the company, it's very much essential for them to store all your personal information, right? It could be for anything, like in case of emergency they should be able to reach out to your family members, or it should be that for them to even process your payroll or do any sort of thing, they require the information of the employees that are present in their organization, right? So every company today securely stores the employees information on their databases, right? So think that this is one such organization is there, which is storing certain important attributes of an employee. Okay, so they are storing information like employee ID, employee name, what is the salary, his age, gender, and department in which he is working. Okay, so each of these columns, these are called fields, and they give certain specific information about an employee, right? Because if you take for this particular employee one, his name is Sam, he's making a salary of $95,000 per annum, and his age is 45 years, and he's a male and works in the operations department of an organization, right? So like that, so each column will talk about only one particular thing for all the employees. Okay, if you take ID, employee ID column, it will only have IDs of the employees. If you take employee name column, it will only have the names of the employees. Like that, each and every column will only have one particular, will convey only one particular information. Yeah guys, so this is what I already discussed. Rows in a table are also called as records, and columns in a table are also called as fields. Okay, so if you go by what is the definition of field is nothing but it provides specific information about the data in a table. So when I say specific information, it is nothing but every column in a table talks about only one thing, right? If you take a salary column, it will only have values corresponding to salary, and it won't contain any values related to age or name or ID. Okay, so that is one of the standard thing. Okay, it should be consistent. You can't say that for another record I will store age of the employee in this column. No, that will contradict what you say, the structure that we have adopted for a table. Okay, so if you are building a table, each column should contain only specific or relevant information corresponding to that column. Yeah guys, so then we have records. as I told, the horizontal entities are called records, and put it formally, each individual entry in a table is called a record. Records or rows, one and the same. Yeah, guys. So that's about tables. So important thing to remember is tables in SQL comprise of rows and columns. Rows are also called records. Columns are also called fields. Okay. Row, the horizontal entity is called a row and the vertical entity is called a column or field. Now let's see how can we create and drop a database. Okay, that is just a minute. So creating a database in SQL is very simple. You just need to write a command create database, and followed by the database you can give the name of your choice for your database. So create database name. This is a syntax to create a database. So let's see that in action in SQL Server Management Studio. Okay, so creating a database. Syntax is create database followed by the database name. Okay, we can think of any database. Let's say we'll create a sales database, or we can also create a customer database. Okay, so I'll just create customer underscore DB. DB means database. Sometimes we use the short form DB to define a database. Okay, DB means database. So create database name will create a database for us. Okay, so once I write this query, I select this line of code and click on execute button. So my code gets compiled and it does execute. Our operation will be successful. Okay, so it says that command completed successfully, which means the creation of database customer DB has been accomplished successfully. Now you guys will get a doubt. How can I check, or where can I check whether this database is created or not? Right? So that's an obvious doubt anyone is gonna get. Right? So there is something called as Object Explorer window in the SQL Server Management Studio, through which you can check the databases that you have created. Even before checking, let me refresh the contents on the Object Explorer window. So I can click on this button to refresh the contents so that my latest changes are visible over here. Okay, so to see, this is a database that we have created. So just go here and expand the databases folder. Okay, because any database that a user has created will come under this databases folder. Okay, so just expand the databases folder, and here you go. This is a customer DB which we have just created. You can right click on it and you can also go to the properties, and you can see when is it created. Okay, just a minute guys. Okay, so you see here, if you go to the properties of the database, okay, to go to the properties of the database, right click on the database, go to the properties, and this pop-up will show certain credentials regarding the database, like when it is created. So if you see, it has been created just a while ago at 3:19 p.m. IST. So you can also see what is the total size of this database, how much space is available, and stuff like that. Okay, yeah guys, so using a simple statement, you can create this database. So this is how you can create a database. And if you want to drop, okay, so you have created, you have used it, after your work is done, you are no longer interested in storing this database. Okay, so then you can conveniently drop the database using drop drop database followed by the database name. Select this line of code, and if you just click on execute, the command get completed successfully. And once you refresh the contents of the Object Explorer, then you will no longer be able to see the customer DB. You see, customer database has been dropped off. So that's simple it is to drop a database. Just by one command you can drop a database. Okay, but however, you need to be very careful when you drop a database. Okay, not all times you will be able to retrieve the dropped database. Okay, important info is present in that database and you accidentally drop that database, then you would be at the loss of data. So you need to double think, and only if you are confident that no info is present that would be of use to you, then only take a decision of dropping a database. Okay, so otherwise don't drop a database because you might be at the loss of data. So this is how, using two different statements, you can either create a database or drop a database. Okay, so I'm rerunning this create database option. Create the database again as we would be making use of that database. Okay, so I just ran this, as now you would be able to see the customer database again. Okay, however, like let's say you first created a database, dumped some data into it and dropped the database. So that data that is present in that database will be lost forever. And if you want to create a same database, you can create database, just the database, blank database will show up. Okay, so the data that would have been present, that had been present previously in this database, that data won't be retrieved, guys. Okay, it's just that you are creating a database again from the scratch. Okay, so don't think that when I create a database again, the data that had been present previously will also come up. No, that won't come up. It's just a new database with the same name gets created, and any data that was in that database before that database was dropped will no longer exist. So one of your friend is also asking, can we undo if we drop the database? Okay, so it depends purely on what kind of access is given to you. Okay, so if you are an admin and you drop a database, I don't think you will be able to retrieve the data back. But sometimes what happens is, depending upon how this SQL Server Management Studio is configured, what happens is, even if you drop the database, people tend to keep a copy of that database before dropping it. Okay, so with that copy, they might be able to retrieve the data. So that happens sometimes, but we can't guarantee that that will be the case always. So hence we need to be extremely careful before dropping a database. In some cases, they might be able to retrieve the data back, provided they have the copy of the database stored somewhere. So let's talk about that is it about creating and dropping databases. Okay, so now let's see how to create tables in SQL. Yeah, guys. So create a table in SQL. There is a syntax. Yeah, guys. So creating a table in SQL needs three important aspects. Okay, so we need to be aware of three important aspects before creating the table in SQL. Okay, first thing is, you need to think of some intuitive name for your table. Okay, let's say that you are planning to create a table in SQL. Then once you plan to do that, you should also be thinking about what should be the relevant name that I need to give to my table. So the name of the table should always be intuitive, so that the users of that table don't get confused. So hence always keep in mind to give an intuitive name to a table. What do I mean by intuitive name is, let's say if you are creating a table which is containing the information of the employees present in an organization, so name the table as employees or employee info or employee attributes. Okay, so don't name it as customers table. Okay, so if you are storing the employee information in a table named customer info, some analyst sitting in some consulting company think that the information that is present in that table pertains to the customers of that company. So that is a wrong sense that would give if you don't name your tables properly. Okay, so it's always important that you name your tables with an intuitive name or a relevant name. Okay, so if you are storing employee information in a table, just give the name as employee info or employee attributes or just employee, something like that. Okay, so that is the first aspect we need to be aware of while creating a table. Then the second aspect is, we need to be aware of what are the columns that we would like to store in that table. So a table is nothing but a combination of columns and rows, right? So you should be you should also be aware of what are the columns that you would like to store in that table. Okay, so if it is an employee table that you are planning to create, then there will be certain attributes for an employee, like his employee ID, employee name, employee date of birth, gender, what do you say, his personal mail ID, phone number, Aadhaar ID, PAN card, bank account number, bank name. All these details company would be interested in storing, right, regarding the employee, because all these details are needed for them to onboard the employee in their organization and also to further process their payroll every month, right? So definitely all the info related to processing the payroll, like bank account number, his Aadhaar number, his PAN card number, his mobile number, all these details are needed for the company so that they can process the payroll every month correctly. So that is the second aspect, is you need to be aware of what should be the columns that you are planning to store in a table. Then the third aspect is assigning the data types to the columns. So to each of the column, you need to assign a relevant data type. Okay. So depending upon the values that go into the column should be given a relevant data type. Okay. So there are broadly three different data types that are available to us, okay, in SQL. So we have three different types of databases, data types. First is the numerical data types. The second umbrella of data types is the character data types. And the third type of data types is date and time data types. Okay. And within each of these umbrella of data types, you have different data types like big int, integer, small int, tiny int, decimal. See, for each of the data types, the only difference is the range of values it can accommodate. So depending upon your use case, depending upon the breadth of values that will go into that column, you can assign the column with any one of these data types. Okay. If it is a character type column, for example, employee name, employee gender, employee department, all these columns will have values as strings, right? In these columns, the names in employee name, for example, will have values like the names of the employees, right? You have Sai, you have Rohit or Akshay, something like this, right? So it is a string that goes into that column, right? So you need to declare that column data type as character data type, right? Either character or varchar or text, something like that. Okay. If you want to store any date related fields, for example, date of birth of the employee or date of joining of the employee, then what you need to do is you need to assign the data type of those columns either as date or time or year. Okay. So depending upon the use case. Okay. So broadly, we have three different data types that are available to us, and within each of those data type buckets, we have actual data types like big int, small int, tiny int, and decimal. Under the numerical data types umbrella, we have character, varchar, and text under the character data types umbrella, and then we have date, time, and year under the date and time data types umbrella. Okay, so this is a third aspect you need to remember while creating the table. Okay, so the first important aspect is thinking of a relevant name to the table. Second aspect is thinking of what are the columns that go into that table. And third aspect is assigning the relevant data types to each and every column. So once these three things are clear in your mind, you can create a table in SQL using this syntax. So the syntax to create the table is like this. You need to write create table followed by a relevant table name, open parenthesis, and within the parenthesis, specify the columns one by one, whatever you need, and just close the parenthesis. Okay. For now, don't think of what is this primary key and all. Okay. Except that you can see the rest of the syntax. It should be like create table, table name, open parenthesis, and within the parenthesis, you specify each and every column along with the data type of that column. Okay. So once you specify the columns of your interest, close the parenthesis, and you can execute that piece of code, which will create a table for you. Okay. So let's see. let's take an example and create employee table. Okay, let's create employee as per the syntax. It should go like create table followed by the table name, and I want to give the table name as employee info. So this is a table name I have chosen for my table. Then I will open the parenthesis and close the parenthesis. Within the parenthesis, I'll specify some of the important columns for my employee info table. The first and important column is the ID. Every employee that joins an organization will get a unique ID, right? No two employees will have the same employee ID, right? Every employee will get a unique ID. Okay, so employee ID I'm defining or declaring as integer data type. Then I would like to give employee name, and I would like to give it as varchar. Okay, and within the varchar, you need to specify what is the maximum size of the employee name. Okay, how many maximum number of characters it should be there, right? So, and generally we don't know, names keep on varying, right? Few people will have 5 characters in their name, few people will have 20 characters in their name, right? So how can we assign what is the argument that I need to give for varchar? Is tricky, right? So just think of some big value like 80 or 100, right? So I don't think any employee's name would extend beyond 80 characters, right? Even 80 is a very big number, but let it be. Maybe we never know. Sometimes there could be people with long names. Okay, so even to accommodate them, we are just putting a big value as 80. Okay, so what happens if you try to give a name which is beyond 80 characters in length? Then your name gets truncated, and only the first 80 characters of your name will be stored, and the rest of the characters will be lost. Okay, but that's a hypothetical case, right? That's never gonna happen. I don't think anyone's name extend beyond 80 characters, right? So for the safe side, just give a very big number as an argument. After name, the other important thing we would like to store about the employee is their gender. Okay, again gender I'm assigning it as varchar 20 randomly, because employee gender will contain values like male and female. Okay, ideally I should have given varchar 6 also, because female means it has got 6 alphabets. This could be the maximum, but just to be on the safe side, I have just given 10 or 20, something like that. Okay, after gender, I would also like to store the employee's salary. Again, I am assigning the data type of employee salary as integer. Then I will also like to store employee department. So E underscore department for storing the department of the employees. Okay, again, I would like to assign as varchar data type with maximum characters being 30. And what else? So let's think of one column related to date data types. So let's say employee's date of birth. Okay, I am assigning the data type of that column as date data type. I can also store employees DOJ or date of joining in the organization. Okay, this is also of date data type. Okay, so like that you can keep on extending the list. You can also store the employees primary mobile number, secondary mobile number, their personal ID, employee's father's name, mother's name, their blood group, account number, PAN card number, all those things. I mean, whatever info that you feel is relevant uh, for your day-to-day needs, you can store all those columns. Okay, for the ease of work, I'm just restricting my columns to these set of columns, and then I can execute this piece of code. Okay, I'll just select only this piece of code and I'll execute it. Okay, so yeah guys, even before executing, I want to make customer DB as my active database. Okay, so this is the database that we have created a while ago. So I would like to make customer database as my active database. Okay, so what happens with the active database is that, so whatever database that you see here, this table will go and sit into this database. Okay, so if it is a master database, that is an active database, And the moment you execute this create table employee info, at the time of execution of this query, whatever is the database that is present here, in that database, this table gets created. Okay, so always make sure that the database in which you want to store the table, make that database as an active database. Active database is nothing but making that database appear over here. Yeah, I want my employee info table to be created in the customer DB database. Hence, I made customer DB as my active database. So after making that database as an active database, I would then execute this piece of code. Yeah, guys. So this is creating a table for me. Okay. So if you see command completed successfully. So if I refresh the contents of the Object Explorer, and if I further expand this customer DB, within that there will be a folder for tables. Okay. So if I expand this tables folder, I should be able to see employee info table. And here you go. So this is the employee info table that we just created. Okay, and if you see, there is a table symbol, right? So this Object Explorer neatly organizes the things along with the symbols. Okay, so since customer database is a database, it is represented with the cylindrical structure. Okay, as I have already discussed, databases are usually represented using the cylindrical shapes. So hence the reason you are seeing a cylindrical shape before customer DB, because customer DB is a database. Within this database, employee info is a table. Okay, hence you see a table symbol before the table name. Okay, so this is how you can create a table. Okay, now let me access this table. Okay, if I want to see what is there in this table, how can I read the contents of the table? Okay, for creating the table, you should be able to access the data that is present in the table, right? For which you need to read the contents of the table. Okay, to read the contents of the table, we would be making use of select clause. Okay, so I write a query select star from employee info. So I'll discuss what is this star, what is this from, and what is this select clause slightly after some time. Okay, but for now, just look at what's happening. I'm trying to retrieve the data that is present in this table. Okay, so I'm just writing that query and executing it. You see in the results window, we only got empty table, or the table with no records. That is because whenever you create the table, only the skeleton of the table gets created, which means it only creates what are the columns that are there in the table and what are the data types of the columns. That info gets stored in the backend. So a create table statement will only create the skeleton of the table on the database. Okay, so populate the rows in this table, we need to make use of insert into statement. Okay, so it's our responsibility to populate this table with the data. Just a create table statement won't populate the table, it will just create the skeleton of the table on the database. And so we have now seen how we can create the tables in SQL. After that, let's see how can I insert data into those tables. Okay, let's see that. So inserting data into tables. Yeah, guys. Straight away write the syntax here itself. Okay. So to insert the data into tables, the syntax goes like this. Insert into followed by, you need to specify the table name into which you want to insert the data. Okay. So insert into this table. What do you need to insert? You need to insert values. So insert into table name, the values, open parenthesis, closed parenthesis, and within the parenthesis, you need to specify the values for each and every column. Okay, so for all the columns that are present in this table, for each column you need to specify one value each per column. Okay, then now gets the doubt, how can I know what are the columns that are present in this table? Okay, you need not be bothered, you just further expand this employee info table, and then you should be able to see a folder for columns. Okay, just expand that columns folder and you would be able to see the columns that are present in this table in the sequential order. Okay, so you see employee ID is the first column for this table, followed by employee name, gender, salary, department, date of birth, and date of joining. Even if I go up, I should be able to see the same columns in the same order. Okay, so now let's try to insert values into this employee info table. And as I told, values need to be entered in the sequential order. Okay, so the first column is employee ID. So let me assign, and it is an integer type data type, right? You can also see the data types of each of these columns beside the column name. Okay, so employee ID is an integer data type column. Employee name is a varchar data type column. Gender again is a varchar data type. Salary is integer. Department is varchar. Employee's date of birth is of date data type, and employee's date of joining is also of date data type. To insert the data into tables, we need to insert one value per column. Okay, first column is employee ID, assigning the value as 1 for the first employee. You should specify the name of the employee. So you can give of some name. Some name I would think of it is Lakshmi. Okay, so Lakshmi is one name. Okay, and if you see for the varchar or character, for these kind of data types, you need to specify the values within single quotes. I repeat, if it is a character type data types, then the values that go into those columns should be specified in single quotes like this. Okay, if it is a numeric data type, no need to specify any quotes. Okay, you can write as it is. Only if it is a character data type, then you need to specify the quotes before and after the value. Then you have third column, which is gender. As I told, gender should be male or female, and Lakshmi is a female name, so let me put female gender. And then you have salary. Let's randomly assign $60,000 as the salary of Lakshmi per annum. And then let's say you have employee salary. Salary is done. Then you have department. So let's assign sales department to Lakshmi. Okay. After sales, after department, you have date of birth and date of joining. So date of birth and date of joining both are of date type data type. So again, date type data types should also be included or enclosed in a single quotes like this. So employee date of birth should be some value. Okay, let me give it as 1994 0820. So while specifying the date, we should be careful of the order in which we write the date, guys. Okay, so it is not as per the Indian way of writing the date. You should always write year first, followed by month, followed by day. Okay, or the exact date. Okay, it should not be other way around. It needs to be specified only in this format. Okay, only if you specify in this format, SQL Server Management Studio will understand that this is a date. Otherwise, it won't understand that it is a date or not. Okay, so we need to first specify the year, followed by the month, followed by the date. Then we need to specify the date of joining of the employee. Let's assume that the employee joined the organization in 2017 in the March month. Let's say 20, randomly coming up with some dates. Okay, so he's born on 20th August 1994. He joined some organization on March of 23rd March 2017. So this will complete one particular record completely, right? We have specified values for each and every column. Okay, so once you are done specifying the values for each and every column, just select that piece of code, just select that line of code and click on execute. So I selected that line of code and my one row got affected. Okay, which means this one row of data got inserted into my table. Okay, so to see that, I'll just rerun this select star from employee info, and you should be able to see one row getting populated in the employee info table. The table has now been populated with one record. whose ID is 1, name is Lakshmi. She's a female, gender category, and she draws a salary of 600,000 and belongs to the sales department, and their date of birth and date of joining. So in this manner, using the insert into statement, we can populate the table that we had created. Okay, so if you want to further populate this table with many records, you can just copy paste this syntax and change the values. Okay, so let me populate this table with at least 4-5 rows, so that we have some enough data to work on in the later sections. So let me run this insert into statement. I think this is run, right? So for the next record, let me change the employee ID to 2. Let me change this name to Robin, who is a male. And let's say Robin draws a salary of $80,000, and let's say he belongs to marketing department. Okay, and let's say his date of birth is 1995 September. Let's say September 15, and let's say he joined the company on 2018 January 30, 20, whatever it is, January 20 or 30. So like this, you can populate the data for each and every record. Okay, so let me change this to 3, 4, 5. I think we have one more row also. We can make this as 6. Okay, so let me quickly change the names. Okay, so let me change this to Siri, who is a female. Let me change this to $70,000. She's also in sales, born in 93, month 25, and let's take date of joining as 2017 June 25. Okay, for the rest of the 3 rows, let me copy paste the values from, yeah guys. So for rest of the just quickly populate it. Okay, after Siri, let's say we have his salary is $90,000. He's in analytics department. He is born in 1992, for example, 8th month 22nd. Joined the company on, let's say, 23rd May 2017. Okay, so let me quickly populate it for the employee. Let's say 5th employee is let's say she's a female too, and her salary is $75,000. She also belongs to sales department. Let's say her date of birth is 1996, 8th of month and 18th date. Her date of joining in the company, let's say, is 2016, May month 25. Yeah, I think 5 records should be okay. So let me delete the last one. You can run the rest of the statements, select them and just click on execute. Yeah guys, let me run line by line. Okay, so one more row got affected. Okay, so this 3rd row also got executed. Let me run this line as well, and one more row got affected. So in total, along with the first insert into statement, we have 4 records in our table, right? So when I do select star from employee info, I should be able to see the 4 records in my table. Okay, yeah, here you go. Yeah guys, so this is how you can, you can populate the table with the data using insert into statement. Okay, so that's all about inserting data into tables. So let's move and discuss how we can access the data that is present in the table using the select clause, from clause, and various other classes. So accessing the data present in the tables. So using the insert into statement, we can populate the table with the data. Now, once the table is populated, we should be able to access the data that is present in the table, right? So to access the data, we can make use of the select clause and from clause. Okay, so to access all the data that is present in the table, what we need to do is select star from. We also need to write from. Okay, and within the from clause or within the from statement, you need to specify the table from which you want to access the data. In this case, I want to access the data from employee info table. Hence, I'm specifying employee info here. Okay, so select these lines of code and just click on execute, which will fetch you the data that is present in employee info table. So very simple, writing a very simple SQL query is this. Okay, select star from table name. Will always fetch you the data that is present in the table. Few people asked me, can I put a semicolon at the end of the query? Okay, so semicolon is optional. If you want to put, you can put it. Even if you don't put it, it is one and the same. Okay, so putting a semicolon or not at the end of the query is completely optional. So generally people tend to put it to mark the end of this query. Okay, so after semicolon, whatever is there, I can write a new query. Okay, so generally coders use semicolon to mark the end of that query. Okay, but from the execution standpoint, it is optional. Yeah guys, so this is how you can access the data that is present in the table using the select clause and from clause. You might be getting a doubt, what is this star mean? Okay, so whenever you specify star, star is a replacement for all the columns. Okay, by putting star, you are telling SQL to retrieve all the columns that are present in employee info table. So select star from employee info, which means you are selecting all the columns from the given table. So I have seen two questions in the chat window. Let me try to address that. One of your friend is asking, can we import data from Excel file into SQL? Yes, absolutely. You can do that. You can always import the data from Excel file and you can create a table out of that Excel file. Okay, that's possible. And one of your friend is saying, is there any other better way to insert values into a table if we have more records? Okay, yeah guys, see, although I have shown you insert into statement to populate the table in real time, um, no one is going to sit there and write this statement to insert data into the employee info table, right? So it is going to happen automatically. Even if you take the case of Amazon or Mintra or any online e-commerce site, the moment you make the transaction on their website, data gets securely stored in their backend systems. Okay, so no one is gonna be there who manually writes and insert into statement, who puts the data corresponding to your purchase order. So it's gonna happen automatically, guys. So those companies would have established some data pipelines in the backend, which automatically captures the sales transaction information from their website or app, and data gets securely collected. It gets transformed and it goes and securely sits on the database. Okay, so the entire thing is called data pipeline, and those companies would have hired some data engineers to do that work. Okay, so there are specific set of people with a specific designations called data engineers who are responsible for creating those data pipelines. Okay, so data engineers create data pipelines and they are responsible for the steady and consistent flow of data from various systems. Okay, yeah guys, and some people need to show how to import data from Excel into SQL. Okay, yeah guys, I can quickly show that to you, but please pay complete attention as it is a multi-step process. So I would need all of your attention here, as I might not be able to repeat it multiple times. So get it in a first shot itself. So for that, let me have some data. Okay, 1 minute guys. So I have this data named sample superstore. Okay, so this is the data that I have with me. So if you see, this is some data corresponding to the orders placed by the customers on some e-commerce site. Think of that way. And it has columns like what is the order ID, the date on which the order is placed, ship date, shipping mode, customer ID, and stuff like that. I'm going to import this data from this Excel file, and I'm going to create a table, SQL table, by importing this data. So let's see that. Yeah guys, so how to import the data? Let's see that from Excel file. So first thing you need to be mindful is that you need to decide upon into which database you want to import that data. So in this case, I want to import that data into this customer DB. In this customer DB database, I want to import the data from Excel file. Okay, so right click on this database. So right click and select tasks option. Okay, so when you select and open this tasks option, under this tasks, so many options are available to us. You need to then select on import data option. Okay, right click tasks and then import data. So once you click on import data option, SQL Server import and export wizard will show up like this. Okay, then you click on next. So once you click on next, it will ask you in the next page, it will ask you for what is the source of your data, or from which data source you want to import the data. In this case, we want to import the data from Excel file. Hence, select the data source as Microsoft Excel. Okay, and in the next section, provide the path to the file that you want to import. Okay, so click on this browse option, navigate to the location where the file is present and point towards that file. So select that file and click open. Then the address of that file will come up over here, and then you need to select the version of your Excel file, which version Excel file you are using. Okay, so in my case it is 97 to 2003 version, because I'm using the older version of Excel in my system. If you guys are using the latest 2012 version of Excel or 2016 version of Excel, you can select those versions. So in this page, it will ask us to provide all the credentials related to the source file. Then you click on next. In the next section, it will ask us to specify what is the destination of that imported data. Okay, where do you want to save that imported data? In this case, I want to create a table out of that imported data, right? Hence, my destination would be SQL Server native client. Okay, so there is an option which states SQL Server native client. You need to select this option because the source data that is present in Excel file should ultimately come into SQL Server, right? So the destination is SQL Server native client. Then it will ask for authentication. Leave it as it is. Use Windows authentication. Then click on next, and again here you just click on next. Then it will show up the different tabs that are present in this Excel file. So if you see, there are three different files, three different tabs: orders, returns, people. Okay, so you need to select the orders tab because we are interested in importing the data that is present in the orders tab. Okay, so hence check mark the orders tab, and on the right hand side it will ask you for what is the table name that you would like to give to this data. Okay, so it should be the destination table name that you need to specify here. I would like to give a name as orders underscore TBL. So I would like to name that imported data, the name of the table, I would like to give it as orders underscore TBL. Okay, orders table. Okay, then click on next. Here you just again click on next and then click on finish. So it will show you the progress of the import, and you see that rows are getting transferred from into SQL table. Okay, so once the process of import is completely successful, you will get a command like this saying import is success and 9,994 rows of data got transferred from Excel into SQL table. Okay, why only these many rows? Because those many rows are present in the Excel file. So all the 9,994 rows that are present in the Excel file now got transferred. A table has been created. So that is how you can import the data from Excel file into SQL, guys. Now, if I want to access that table, again, we need to check whether it got imported correctly or not, right? So first refresh the contents on the Object Explorer window, click on databases and go to the database into which you imported the data. In this case, I imported my data into customer database. So I'll further expand that customer database. I'll go into tables, and here you go. is a table that I just created by importing data from Excel file. If I want to access this table, I just write select star this table. So whenever you drag the any object from Object Explorer to the query editor, it will always come with an extension of DBO. As a prefix, you will get it as DBO dot. DBO is nothing but database object. Okay, so this table orders underscore TBL is a table which is a database object for the customer database, right? So hence the reason you get prefix as DBO. DBO means database object. So let me run this one line of code to see the contents in my orders table. Yeah, here you go. So my query got executed successfully, and there are 9,995 rows in my orders table. Very simple, guys. So in this way, you can import the data from Excel into SQL, and you can start practicing writing the queries to fetch the data, and you can do all sorts of manipulations with the various clauses that you are going to learn. Okay, yeah, guys. So from now on, let's use this table for all our queries. Okay, cool. So before I shown you how to import the data from Excel file, we were discussing about how can we access the data present in the table, right? As I told, we can make use of the select clause and from clause to access the data that is present in the table. Okay, so select star from table name will give you all the rows and all the columns that are present in the table. Okay, but if you want only specific columns, if you want to extract only few columns, let's say you only want order ID and customer ID from this table, you are not interested in looking at all the columns, you are only interested in looking at order ID and customer ID, then how to write a query to fetch only those two columns of data? It's very simple. Just in the select clause, specify only the columns that you need. You need order ID, comma, need customer ID, right? So just specify these two columns from this table. Just write this piece of code and just select it and execute it. Okay, then you will only get only those two columns of data that you have specified in the select clause. Okay, so in this way, if you don't want all the columns of data to be extracted from the table, then specify only the columns that you need. And if you want all the columns, then specify star. No need to write all the columns one by one. You can just specify star in the select clause, and star would act like a replacement for all the column names. Okay, so star means it will always fetch you all the columns of data. And one of your friends is asking one question, guys. So whenever I import data from an Excel file, how are the data types assigned to each and every column? Okay, it's a good question. This orders table, I have directly imported the data for this table, right? So now if you see, for each and every column, data types are already assigned. So in those cases, the data types assignment will happen automatically, depending upon the values that are present in these columns. Okay, so in the backend, SQL would read, the SQL server would read the contents of each and every column, and it will read and understand what values are present in each and every column, and it will assign the data types automatically. So it would have read the values that are present in the row ID column, and it has assigned float data type. It would have read the contents of the ship date, and all the contents of the ship date column are dates. Hence, date time data type is assigned to such column. Okay, so basically, assignment of data types to the columns happen automatically whenever you import data from Excel files or any other files. This is about select clause and from clause, which are very powerful clauses to extract the data from the tables. Okay, so select clause and from clause are done. Now let's move ahead and discuss what is where clause. Okay, so where clause in SQL helps us to subset the data or filter the data. Okay, so what I mean by that is, so sometimes what happens is for your analysis, you are not interested in looking at the whole of the data. Rather, you would want to look at only a subset of data. Okay. Let's say, for example, you are working with Flipkart. Okay, and you're working with Flipkart in the electronics department of the Flipkart. Okay, Flipkart sells a lot of items on its website, right? They sell all kinds of different categories of products, right, from clothing to furniture, right? So like that, electronics is one product category, right? So you're working as a product analyst with the electronics category within Flipkart. So now you're as you're working as a product analyst in only electronics department, you would be interested in looking at all those transactions which are related to electronics. Okay, you are not interested in looking at the sales or the transactions pertaining to what do you say, clothing, or pertaining to furniture or any other product category, right? So in those cases, what you need to do is you need to subset uh, the data of your interest from the whole of transactions data of Flipkart. So in those cases where you are only interested in looking at part of data but not the whole of data, then you need to make use of where clause. Okay, where clause helps you to subset the data or filter the data of your choice. Okay, so let's say in this example of orders data, let's see what column I can make use of to subset the data. I think we have, yeah guys, we have a category column in the orders table, that we have just created. Okay, and category can be any one of the three categories that we have, like furniture, office supplies, and technology. Okay, so these are the three different categories that we have in the data. Okay, I know this because I have already worked on this data, so I know what column contains what values. So yeah, I'm sure that this category column has only three different values, which are furniture, office supplies, and technology. Now someone is interested in only looking at all those records where the category is furniture. Someone wants to analyze only the furniture related sales. Okay, so they would only want to extract the data pertaining to furniture product category. So now let's see how we can extract only the furniture data. The rest of the query remains same. You can just write select star from orders table, where you can just write where category is equals to furniture. Category is equals to furniture. Again, for category is a string data type, so you need to specify the values inside the single quotes. Okay, so in this way, using the where clause, we will be able to subset the data of our choice. Okay, now if you see, previously we had 9,994 rows pertaining to all the different product categories. Now when I filtered only for the furniture product category, I've got only 2,121 rows. So in this way, I have subsetted my big table, fetch or get only the data of my choice. Within the where clause, you can use different operators that are available within the where clause, okay, which helps us to do some complex filtering. Let's say if you want, if the criteria is like, okay, I want furniture category records, and the state should be California. I want all the furniture. I want to see all the furniture sales that are happening in the state of California. So that is a two criteria. First thing is category should be furniture, and the second filter criteria is state should be California. Okay, so basically someone wants to see all the furniture orders coming from the state of California, or furniture orders placed from California state. So here, if you see, there are two filter criteria. Okay, first filter criteria is based on the category, Other filter criteria is based on the state. So how can we write a query for this? We need to make use of AND operator that is present to accomplish this. Okay. So I'm interested in category of furniture, and along with that state. So state should be California, right? Then I should put it as okay. So in this way you can, what do you say, you can do the complex filtering and operator. So I can click on this, and if you see, now I have got only 444 rows, which means there are only 444 rows that are present in my data, which has the state as California and product category as furniture. Okay, so like that I can filter only the data of my interest using the where operator and the AND operator that is present. So sometimes someone wants to see the orders or records where state is either California or Alabama. Like you want subset all the data belonging to the state of California or Alabama. So even if state is either California or either Alabama, they want us to fetch that data. Okay. So very simple. Instead of AND operator, you should make use of OR operator in such scenarios. So here both the criteria are based on state only. State should be either California or Alabama. We can write the query like this, where state is Alabama or California. You see, we got 2062 records from the table, which belong to the state of Alabama or California. Okay. Yeah. So in this way, you can subset the data using the where clause. Okay. So that's about the where clause. Next, let's discuss about the group by clause and having clause. Yeah, guys. So group by clause in SQL helps us to aggregate the data. Okay. Sometimes questions would be raised like this. Okay. Hey, can you tell us category wise what are the sales? Category wise total sales and total profit. So sometimes you are faced with these questions. Someone, your product manager, wants to look at category wise what are the sales and profit. Okay. When he says category wise, we have three different categories, right? We have furniture product category, office supplies, and then you have technology category. So for each of these categories, they would like to see the total sales and total profit. So someone is interested in looking at kind of output table. Okay. So right now the data that you have is in the form of is at a order level. Okay. For each and every order, you have one row corresponding to that. Okay. It's not even at a order level. It is at a order product level. Within a same order, if you had placed 5 different products, then 5 different rows would have been recorded for that order, same order. You see, for example, row number 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. So all these rows that I have highlighted, they all have the same order ID, if you see. But why so many rows are there for the same order ID? Because there are multiple products that are purchased in the same order. Okay. And since my data is at a order ID, product ID level, so there is one row corresponding to each product ID, order ID combination. Okay. So this is one product that is purchased. This is yet another product. This is the third product, fourth, fifth, sixth, seventh, like that. We have 6 different products that are purchased in the same order. Hence, the order ID is same for all of those 6 orders, whereas the product name is different, right? So now they want us to get the sales category wise. For each category, what is my total sales and total profit? So in cases like this, we need to make use of the group by clause to aggregate the data. Okay. So by aggregation, I mean to change the level of data of the table. Okay. So we have the data at this level, but what I need is the aggregated data. Okay. At a category level, I need the total sales and total profit. So which means I need to sum up all the sales happening for the technology product category. I need to sum up all the sales and profits that are happening for office supplies product category. Then I need to sum up all the sales and profits for furniture product category, right? So what I need to do is I first need to create 3 different groups, and then for each of these groups of product categories, I can sum up their sales and profit. Okay. So to create 3 different groups based on the product category, I need to make use of the group by clause. Okay. So the query goes like this: select, don't specify anything for now in the select clause. We will come back to it later. So I need to select data from orders table. Then you do the group by. By specifying the group by, you are creating different groups, and based on what you are basing the grouping the records. In this case, I want to group the records based on category. So specify category here. So I'm grouping the records based on the category column, and whatever category that you specify, that's also select in the that should also be written in the select clause. Okay. So for each of the categories, you need to sum the sales, you need to sum the profit. Yeah, guys. So in this way, you need to write the query where you are calculating the category wise total sales and total profits. Okay. So this sum is called an aggregate function. Okay. So it is aggregating the data and calculating the sum for those aggregated set of records. So by executing this query, you would now be able to see category wise what are the total sales and total profits. Now if you see, we have so many digits after the decimal point. I can round it off to 2 decimal points using the round function. Round off sum of sales comma 2, round off sum of profits. So I have rounded off the values to only just 2 decimal points. Okay. So that I can see only 2 decimal values or 2 digits after the decimal point. Yeah, guys. So in this way, we'll be able to see the category wise total sales and total profit. So group by helps us to aggregate the data and calculate any aggregated metrics like sum, count, min, max, average. All these kind of metrics we can calculate with the help of group by clause. Okay. Let's see another example where we calculate state wise. Okay. State wise total sales, average sales, minimum sales value to maximum sales value, and count of orders. So someone wants to look at for each of the states, what is the total sales that got recorded from that state, what is the average sales, what is the minimum number of sales, maximum sales. When I say minimum sales, what is the minimum value of the order, minimum order value that we received from that state, and what is the maximum order value that we received from that state, and also the count of orders per each state. Yeah, guys. So here we need to do the group by based on the state. So hence specify state group by state. The same column should also be written here in the select clause. Okay. So for each state, what is that we need? First thing is we need total sales. So do the sum of sales, which will give you the total sales. Then you need to find out the average sales. Okay. For average sales, we would make use of average function and do the average of sales. Okay. Average of sales as you can using the alias, you can alias this column name. Okay. You can give a substituted name for that column. Okay. So I will call this as average sales. Okay. Then you need to find the minimum of sales. So use the min function to get the minimum value of sales as alias that as minimum sales. Then use the max function to get the max of sales and alias that has max sales. And lastly, what do you need? Count of orders. So do the count of distinct order ID. Okay, I need to use the distinct keyword here because my order ID is repeating across the rows. Okay, hence I want to count the distinct order IDs, count of distinct order ID as, yeah guys. So in this way we can calculate at a state level what are the different metrics that one would like to look at. Okay, so I'll just run this query, we get the answer. You see, for each of the states, for each of the 49 states, I think we have 50 states in United States of America, but only 49 states, uh, from 49 states we have seen the order that were placed. Okay, and for each of the states you are seeing what is the total sales value that happened from this state, what is average sales, minimum sales value, maximum sales value, how many distinct orders are placed in from this state. Okay, so in this way we can get the summary of data, summarized metrics we can get from the given data using the group by clause. Very important guys, as far as uh, analysis, data analysis using SQL data is concerned, group by clause is very important because it helps you to summarize the data. Okay, yeah guys, so that's it about the group by clause. Now let's see the functionality of the having clause. Yeah guys, so having clause in SQL also helps us to do the filtering of data, but the way having clause works is slightly different from the way where clause works. Okay, because even if you see, where clause also helps us to subset the data, right? Subset or filter the data, and even having clause also helps us to subset the data, right? Then where is the difference in between these two clauses, and why in the first place we have two different clauses to do the filtering, right? This kind of questions comes to our mind, right? Yes, there is a slight difference between a where clause and having clause. Okay, so the way where clause does function to do the filtering is different from how the having clause works. Okay, so point to be noted over here is that both where clause and having clause does the functionality of filtering the data, but the way they work is different. Okay, so let's see what is that difference. So having clause should always be used in conjunction with group by clause. Okay, so you can't use a having clause independently without the group by clause. Okay, so having clause should always be written after the group by clause. Okay, whereas where can be used, or where clause can be used without group by clause as well. Okay, so there is no necessity, there is no mandate for us to use group by whenever there is a where clause. No, there's no mandatory thing like that. Okay, but whenever you use say having clause, group by clause needs to be specified definitely. Okay, having clause needs to be written only after the group by clause. Okay, whereas where can be written even without the group by clause. Okay, yeah. And how having does the filtering is, having does the filtering based on aggregated data. Okay, whereas where does the filtering based on unaggregated data or raw data. So let's see what do I mean by having does the filtering based on aggregated data. Okay, sometimes you get the questions like, hey, can you show me only those states average sales value greater than 200. Okay, some product manager is looking at the sales, some sales manager is looking at the sales, and he is only interested in looking at all those states which has average sales value greater than 200. Okay, so the way to go about tackling this kind of questions is, first you need to get the state wise average sales, and then after that you need to subset that aggregated table to show only those states which have got average sales value greater than 200, right? So this is a two-step process. First is find the state wise average sales value for each of the state, and then limit your rows to only those states having average sales value greater than 200. Okay, so this is very simple. We just need to make use of having clause to answer these kind of questions. So firstly, we are calculating the state wise average sales. The rest of the metrics are not needed, so just removing them. So we are just getting the state wise average sales for each of the states. Then we need to limit our output to only those states. Okay, let me remove this round function also in order to avoid confusion. And then we need to show only those states which has average sales value greater than 200. Okay, so to specify the same, you need to write like this: group by state and having average of sales greater than 200. Now if you see, in the previous case we got 49 rows when we did the state wise average sales, total sales, count of orders and stuff like that. But when we put the filter using the having clause and limiting the data so that we only show all those states which has average sales value greater than 200. Okay, so in this way having clause is used to subset the data after the aggregation is done. Okay, so if you see, I am limiting my aggregated data. Okay, in the previous case when I used only group by without having clause, what happened is I got for each of the states I got all the metrics. Now if I want to show only the states having average sales value greater than 200, I am limiting or subsetting my aggregated table to only those states which fulfill the criteria of average sales value. So in this way, having is used to subset the aggregated table, and it should always be used after the group by clause. Yeah, guys. So that's it about the having clause. Let's move further. Then what do we have after having? We have the order by clause and top clause. Okay, so let's discuss that. So order by clause is used to order your rows, sort your rows however you want. Okay, so let's say if I want to sort my rows in the orders table based on the sales value. Okay, in the descending order of sales value. Okay, sort the rows in the descending order of value. Okay, if you want to sort the rows in the orders table in the descending order of sales value, what we can do is we can make use of order by clause to do the same. Okay, so select start from orders table, dbo orders table. Then what I can do is the order by clause, and you can mention you need to order by what. In this case I want to order it in the descending order of sales value. So order by sales, put DESC. DESC means descending. So when I just do this, I will get my rows in the orders table which are sorted in the descending order of sales value. Okay, so if you see, the highest sales value order is placed at the top. So 22,638, then followed by 17,499. As you come down, the sales value decreases. Okay, that is a descending sort. Yeah, guys. So then we have the top clause. Okay, so top clause helps us to what do you say, fetch only the top n records. Okay, sometimes they say, hey, fetch me top 3 states by total sales. Okay. They're always interested in looking this top 2, top 3, top 5, right? Everywhere, like even in when Olympics happen, people are only interested in looking at the top 3 performers, right? So the top performer is going to get a gold medal, then second performer is going to get a silver medal, and then the bronze medal, right? So generally whenever you are dealing with any data, sales managers or product managers are interested in looking at top 3 categories or top 3 cities or top 3 states, right? So they are not interested in looking at everything, they just want top 3 things. Okay, in such cases what we can do is we can make use of the top clause to filter only the top n records. Okay, so if you want to get the top 3 records by total sales, what I can do is, the top 3 states by total sales. What I can do is, I can do this. Okay, first I will calculate state-wise total sales, for which I would make use of sum function, sum of sales as total sales. Then I order my data, order by total sales descending, and I'll in the select clause I can mention the top. Okay, so select top 3 state comma total sales from this, and like this you need to mention. So this will only give the top 3 states by total sales. Okay, so the California is the state with the highest total sales, followed by New York, and then followed by Texas. Okay, so these are the three states from which have recorded maximum total sales, and these are the top 3 states in terms of sales volume. Okay, yeah guys, so this is about the order by clause and the top clause. Okay, yeah guys, so that's it for today. See you all.
Thank you guys for attending the session. Thank you so much, sir, to give us this much knowledge about the SQL. And thank you for this fruitful session. Thank you, sir.